Chapter 11 of Curiosities of the Sky. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Greg Bell. Curiosities of the Sky by Garrett Serviss. Chapter 11. Meteors, Fireballs, and Meteorites. One of the most terrorizing spectacles with which the heavens have ever caused the hearts of men to quake occurred on the night of November 13th, 1833. On that night, North America, which faced the storm, was under a continual rain of fire from about 10 o'clock in the evening until daybreak. The fragments of a comet had struck the earth. But the meaning of what had happened was not discovered until long afterward. To the astronomers, who, with astonishment not less than that of other people, watched the wonderful scene, it was an unparalleled shower of meteors. They did not then suspect those meteors had once formed the head of a comet, light dwarfed when, a year later, Professor Denison Olmsted of Yale College demonstrated that the meteors had all moved in parallel orbits around the sun, and that these orbits intersected that of the Earth at the point where our planet happened to be on the memorable night of November 13th. Professor Olmsted even went so far as to suggest that the cloud of meteors that they had encountered at the Earth might form a diffuse comet, but full recognition of the fact that they were cometary debris came later, as a result of a further investigation. The key to the secret was plainly displayed in the spectacle itself, and was noticed without being understood by thousands of the terror-stricken beholders. It was an umbrella of fire that had opened overhead and covered the heavens. In other words, the meteors all radiated from a particular point in the constellation Leo, and being countless as the snowflakes in a winter tempest, they ribbed the sky with fiery streaks. Professor Olmsted showed that the radiation of the meteors from a fixed point was an effective perspective, and in itself a proof that they were moving in parallel paths when they encountered the Earth. The fact was noted that there had been a similar, but incomparably less brilliant, display of meteors on the same day of November 1832, and it was rightly concluded that these had belonged to the same stream. Although the true relationship of the phenomena was not immediately apprehended, Olmsted ascribed to the meteors revolution about the sun once in every 6 months, bringing them to the intersection of their orbit with that of Earth every November 13th. But later investigators found that the real period was about 33 1/4 years, so that the great displays were due 3 times in a century, and their return was confidently predicted for the year 1866. The appearance of the meteors in 1832, a year before the great display, was ascribed to the great length of the stream which they formed in space, so great that they required more than 2 years to cross the Earth's orbit. In 1832, the Earth had encountered a relatively rare part of the stream, but in 1833, on returning to the crossing place, it found there the richest part of the stream pouring across the orbit. This explanation also proved to be correct, and the predicted return in 1866 was duly witnessed, although the display was less brilliant than in 1833. It was followed by another in 1867. In the meantime, Olmsted's idea of cometary relationship of the meteors was demonstrated to be correct by the researchers Schiaparelli and others, who showed that not only the November meteors, but those of August, which are seen more or less abundantly every year, traveled in the tracks of well-known comets, and had undoubtedly an identical origin with those comets. In other words, the comets and the meteor swarms were both remnants of the original masses, which had probably been split up by the action of the sun or of some planet to which they made close approaches. The annual periodicity of the August meteors was ascribed to the fact that the separation had taken place so long ago that the meteors had become distributed all around the orbit, in consequence of which the Earth encountered some of them every year when it arrived at the crossing point. Then Leverrier showed that the original comet associated with the November meteors was probably brought into the system by the influence of the planet Uranus in the year 126 of the Christian era. Afterward, Alexander Herschel identified the tracks of no less than 26 meteor storms, most of them inconspicuous, with those of the comets. The still more recent researches of Mr. W. F. Denning made it probable that there are no meteors which do not belong to a flock or system probably formed by the disintegration of a cometary mass. Even the apparently sporadic ones which shoot across the sky, as lost souls of the night, bring members of flocks which have become so widely scattered that the earth sometimes takes weeks to pass through the region of space where their paths lie. The November meteors should have exhibited another pair of spectacles in 1899 and 1900, and their failure to do so caused at first much disappointment, until it was made plain that a good reason existed for their absence. It was found that after their last appearance in 1867, they had been disturbed in their movements by the planets Jupiter and Saturn, whose attractions had so shifted the position of their orbit that it no longer intersected that of the Earth as it did before. Whether another planetary interference will sometime bring the principal mass of the November meteors back to the former point of intersection with the Earth's orbit is a question for future to decide. It would seem that there may be several parallel streams of the November meteors, and that some of them, like those in August, are distributed entirely around the orbit, so that every mid-November we see a few of them. We come now to a very remarkable example of the disintegration of a comet and the formation of a meteor storm. In 1826, Biela of Jovenstadt, Austria, discovered a comet to which his name was given. Calculations showed that it had an orbital period of about 6½ years, belonging to Jupiter's family. On one of its returns in 1846, it astonished its watchers by suddenly splitting into two. The two comets thus formed out of one, separated to a distance about 160,000 miles, and then raced side by side, sometimes with a curious ligature connecting them, like Siamese twins, until they disappeared together in interplanetary space. In 1852 they came back, still nearly side by side, but now the distance between them had increased to 1.25 million miles. After that, at every reoccurrence of the period, astronomers looked for them in vain, until 1872, when an amazing thing happened. On the night of November 28th, when the Earth was crossing the plane of the orbit of the missing comet, a brilliant shower of meteors burst from the northern sky, traveling nearly in track which the comet should have pursued. The astronomers were electrified. Klinkerfues and Göttingen telegraphed to Posden of Madras. Biela touched Earth. Search near Theta Centauri. Pogson searched in the place indicated, and saw a cometary mass retreating into the southern heavens, where it was soon swallowed from sight. Since then, the Biela meteors have been among the recognized periodic spectacles of the sky, and few if any doubt that they represent a portion of the missing comet whose disintegration began with the separation into two parts in 1846. The comet itself has never since been seen. The first display of these meteors, sometimes called the Andromedes, because they radiate from the constellation Andromeda, was remarkable for its great brilliancy of many fireballs that shot among the shower of smaller sparks, some of which were described as equaling the full moon in size. None of them is known to have reached the earth, but during the display of the same meteors in 1885, a meteoric mass fell at Marzapil in northern Mexico. It is now in the museum at Vienna, which many have thought may actually be a piece of the original comet Biela. This brings us to the second branch of our subject. More rare than meteors, or falling stars, and more startling, except that they never appear in showers, are the huge balls of fire that occasionally dart through the sky, lighting up the landscapes beneath their glare, leaving trains of sparks behind them, often producing pearls of thunder when they explode, and in many cases falling upon the earth and burying themselves from a few inches to several feet in the soil, from which more than once they have been picked up while yet hot and fuming. These balls are sometimes called bolides. They are not really round in shape, although they often look so while traversing through the sky, but their forms are fragmentary and occasionally fantastic. It has been supposed that their origin is different from that of true meteors. It has even been conjectured that they may have originated from the great volcanoes of the moon, or may have been shot out from the sun during some of the tremendous explosions that accompany the formation of eruptive prominences. By the same reasoning, some of them might be supposed to have come from some distant star. Others have conjectured that they are wanderers in space, of unknown origin, which the Earth encounters as it journeys on, and Lord Kelvin made a suggestion, which has become classic because of its imaginative reach, that the first germs of life may have been brought to Earth by one of these bodies, a fragment from an exploded world. It is a singular fact that the astronomers and scientific men in general were among the last to admit the possibility of solid masses falling from the sky. The people had believed in the reality of such phenomena from the earliest times, but the savants shook their heads and talked of superstition. This was the less surprising because no scientifically authenticated instance of such an occurrence was known, and the stones popular believed to have fallen from the sky had become the objects of worship or superstitious reverence, a fact not calculated to recommend them to scientific credence. The celebrated black stone, suspended in the Kaaba at Mecca, is one of these reputed gifts from heaven. The palladium of ancient Troy was another, and a stone which fell near Eschenheim in Germany was placed in a church as an object to be religiously venerated. Many legends of falling stones existed in antiquity, some of them curiously transfigured by the imagination, like the lion of Peloponnesus, which was said to have had sprung down from the sky upon the Isthmus of Corinth. But near the beginning of the 19th century, in 1803, a veritable shower of falling stones occurred at La Galle in northern France, and this time astronomers took note of the phenomenon and scientifically investigated it. Thousands of the strange projectiles came from the sky on this occasion and were scattered over a wide array of country, and some buildings were hit. 4 years later, another shower of stones occurred at Weston, Connecticut, numbering thousands of individuals. The local alarm created in both cases was great, as well it might be, for what could be more intimidating than to find the blue vault of heaven suddenly hurling solid missiles at homes of men? After these occurrences, it was impossible for the most skeptical to doubt any longer, and the regular study of aerolites, or meteorites, began. One of the first things recognized was the fact that fireballs are solid meteorites in flight, and not gaseous exhalations in the air, as some had assumed. They burn in the air during their flight, and sometimes, perhaps, are entirely consumed before ever reaching the ground. Their velocity before entering the Earth's atmosphere is equal to that of the planets in their orbits, from 20 to 30 miles per second, a fact which proves that the sun is the seat of the central force governing them. Their burning in the air is not difficult to explain. It's the heat of friction which so quickly brings them to incandescence. Calculation shows that a body moving through the air at a velocity about a mile per second will be brought superficially to the temperature of red heat by friction of the atmosphere. If its velocity is 20 miles per second, the temperature will become thousands of degrees. This is the state of affairs with a meteorite rushing into the Earth's atmosphere. Its surface is liquefied within a few seconds after the friction begins to act, and the melted and vaporized portion of its mass is swept backwards, forming the train of sparks that follows every great fireball. However, there is one phenomenon connected with the trains of meteorites which has never been satisfactorily explained. They often persist for long periods of time, drifting and turning with the wind, but not ceasing to glow with a phosphorescent luminosity. The question is, whence comes this light? It must be light without heat, since the fine dust or vapor, of which the train can only consist, would not retain sufficient heat to render it luminous for so long a time. An extremely remarkable incident of this kind occurred on February 22, 1909, when an immense fireball that passed over southern England left a train that remained visible during 2 hours, assuming many curious shapes as it was drifted about by the currents in the air. But notwithstanding the enormous velocity with which meteorites enter the air, they are soon slowed down to a comparatively moderate speed, so that when they disappear, they are usually traveling not faster than a mile a second. The courses of many have been traced by observers situated along their track at various points, and thus a knowledge has been attained of their height above the ground during their flight and the length of their visible courses. They generally appear to within 5 miles of the ground, unless the observer happens to be near the striking point, when he may actually witness the fall. Frequently they burst while high in the air, and their fragments are scattered like shrapnel over the surface of the ground, sometimes covering an area of several square miles, but of course not thickly. Different fragments of the same meteorite may reach the ground at points several miles apart. The observed length of their courses in the atmosphere varies from 50 to 500 miles. If they continued a long time in flight after entering the air, even the largest of them would probably be consumed to the last scrap. But their fiery career is so short on account of their great speed that the heat does not have time to penetrate very deeply, and some that have been picked up immediately after their fall have been found cold as ice within. Their size after reaching the ground is variable within wide limits. Some are known which weigh several tons, but the great majority weigh only a few pounds, and many only a few ounces. Meteorites are of two kinds, stony meteorites and iron meteorites. The former outnumber the latter 20 to 1, but many stone meteorites contain grains of iron. Nickel is commonly found in iron meteorites, so it might be said that the redoubtable alloy nickel-steel is of cosmic invention. Some 25 chemical elements have been found in meteorites, including carbon and the sun metal, helium. The presence of the latter is certainly highly suggestive in connection with the question of the origin of meteorites. The iron meteorites, besides metallic iron and nickel, of which they are almost entirely composed, contain hydrogen, helium, carbonic oxide, and about the only imaginable way in which these gases could become absorbed in the iron would be through immersion of the latter, while in a molten or vaporized state, in a hot and dense atmosphere composed of them, a condition which we know to only exist in the envelopes of the sun and the stars. The existence of carbon in the Canyon Diablo iron meteorites is attended by a circumstance of the most singular character, a very fairy tale science. In some cases the carbon has become diamond. These meteoritic diamonds are very small nevertheless. They are true diamonds, resembling in many ways the little black gems produced by Moissan's method with the aid of electric furnace. The fact that they are found embedded in these iron meteorites is another argument in favor of the hypothesis of the solar or stellar origin of the latter. To appreciate that, it is necessary to recall the way in which Moissan made his diamonds. It was by a combination of the effects of great heat, great pressure, and sudden or rapid superficial cooling on a mass of iron containing carbon. When he finally broke open his iron, he found it a pudding stuffed with miniature black diamonds. When a fragment of the Canyon Diablo meteoric iron was polished in Philadelphia over 15 years ago, it cut the emery wheel to pieces, and examinations showed that the damage had been effected by microscopic diamonds peppered throughout the mass. How were those diamonds formed? If the sun or Sirius was the laboratory that prepared them, we can get a glimpse at the process of their formation. There is plenty of heat, plenty of pressure, and an abundance of vaporized iron in the sun and the stars. When a great solar eruption takes place, masses of iron which have absorbed carbon may be shot out with a velocity which forbids their return. Plunged into the frightful cold of space, their surfaces are quickly cooled. As Moissan cooled his prepared iron by throwing it into water, and thus the requisite stress is set up within, and as the iron solidifies, the included carbon crystallizes into diamonds. Whether this explanation has a germ of truth in it or not, at any rate it is evident that the iron meteorites were not created in the form in which they come to us. They must once have been parts of immeasurably more massive bodies than themselves. The fall of meteorites offers an appreciable though numerically insignificant peril to the inhabitants of the earth. Historical records show perhaps 3 or 4 instances of people being killed by these bodies. But for the protection afforded by the atmosphere, which acts as a very effective shield, the danger would doubtless be very much greater. In the absence of an atmosphere, not only would more meteorites reach the ground, but their striking force would be incomparably greater, since, as we have seen, the larger part of their original velocity is destroyed by the resistance of the air. A meteorite weighing many tons and striking the earth with a velocity of 20 to 30 miles per second would probably cause frightful havoc. It is a singular fact that recent investigations seem to have proved that an event of this kind actually happened in North America, perhaps not longer than 1,000 or 2,000 years ago. The scene of the supposed catastrophe is in the northern central Arizona at Coon Butte, where there is a nearly circular crater in the middle of a circular elevation or small mountain. The crater is somewhat over 4,000 feet in diameter, and the surrounding rim, formed in upturned strata, and ejected rock fragments rises at its highest point 160 feet above the plain. The crater is about 600 feet in depth, that is, from the rim to the visible floor or bottom of the crater. There is no evidence that volcanic action has ever taken place in the immediate neighborhood of Coon Butte, but the rock in which the crater has been made is composed of horizontal sandstone and limestone strata. Between 300 and 400 million tons of rock fragments have been detached, and a large portion hurled by some cause out of the crater. These fragments lie concentrically distributed around the crater, and in large measure form the elevation known as Coon Butte. The region has been famous for nearly 20 years on account of the masses of meteoric iron found scattered about and known as Canyon Diablo meteorites. It was one of these masses, which consists of nickel iron containing a small quantity of platinum, and of which all some 10 tons have been recovered for sale to the various collectors throughout the world, that as before mentioned destroyed the grinding tool at Philadelphia through the cutting power of its embedded diamonds. These meteoric irons are scattered about the crater hill in concentric distribution to a maximum distance of about 5 miles. When the suggestion was first made in 1896 that a monster meteorite might have created by its fall this singular lone crater in stratified rocks, it was greeted with incredulous smiles. But since then the matter has assumed a different aspect. The Standard Iron Company, formed by Messrs. Behringer and Tillman, Bennett, Halsinger, have become in 1903 the owner of this freak of nature, sunk shafts and bored holes to a great depth in the interior of the crater, and also trenched the slopes of the mountain, and the result of their investigations has proved that the meteoric hypothesis of origin is correct. See the papers published in the Proceedings of the Academy of Natural Sciences of Philadelphia, December 1905, wherein it is proved that the United States Geological Society was wrong in believing this crater to have been due to a steam explosion. Since that date there has been discovered a great amount of additional confirmatory proof. Material of unmistakably meteoric origin was found by means of the drills, mixed with crushed rock to a depth of 600 to 700 feet below the surface of the crater, and a great deal of it has been found admixed with the ejected rock fragments on the outer slopes of the mountain, absolutely proving synchronism between the two events. The formation of this great crater and the falling of the meteoric iron out of the sky, the drill located in the bottom of the crater was sent, in a number of cases much deeper, over 1,000 feet, into unaltered horizontal red sandstone strata. But no meteoric material was found below this depth, 700 feet, or between 11 and 1,200 feet below the surface of the surrounding plain, which has been assumed as being about the limit of penetration. It is not possible to sink a shaft at present, owing to the water which drains into the crater, and which forms with the finely pulverized sandstone, with a very troublesome quicksand encountered at about 200 feet below the visible floor of the crater. As soon as this water is removed by pumping, it will be easy to explore the depths of the crater by means of shafts and drifts. The rock strata, sandstone and limestone, of which the walls consist, present every appearance of having been violently upturned by a huge body, penetrating the earth like a cannonball. The great aspect of the crater strikingly resembles the impression made by the steel projectile shot into an armor plate. Mr. Tillman has estimated that a meteorite of about 500 feet in diameter, and moving with a velocity of about 5 miles per second, would have made just such a perforation upon striking rocks of the character of those found at this place. There was some fusion of the cooling masses, and the heat produced some steam from the small amount of water in the rocks. As a result, there has been found at a depth a considerable amount of fused quartz, at which innumerable particles or sparks of fused nickel iron, a projectile of that size penetrating 11 to 1,200 feet into the rocky shell of the globe, must have produced a shock which was perceptible 700 miles away. The great velocity ascribed to the supposed meteorite at the moment of striking could be accounted for by the fact that it probably plunged nearly vertically downward, for it formed a circular crater in the rocky crust of the earth. In that case, it would have been much less retarded by the resistance of the atmosphere than are meteorites which enter the air at a lower angle and shoot ahead hundreds of miles until friction has nearly destroyed their original motion when they drop upon the earth. Some meteoric masses of great size, such as Peary's iron meteorite found at Cape York, Greenland, and the most equally large mass discovered at Rosarito, Mexico, appear to have penetrated but slightly on striking the Earth. This may be explained by supposing that they are pushed along a long horizontal course through the air before falling. The result would be that their original velocity having been practically destroyed, they would drop to the ground with a velocity nearly corresponding to that which gravity would impart within a perpendicular distance of their final fall. A 660-pound meteorite, which fell in Nakrai, Hungary, striking at an angle of 27 degrees from the vertical, penetrated the ground to a depth of 11 feet. It has been remarked that the Coon Butte meteorite may have fallen not longer ago than a few thousand years. This is based on the fact that the geological indications favor the supposition that the event did not occur more than 5,000 years ago, while on the other hand the rings of growth in the cedar trees growing on the slopes of the crater show that they have existed there about 700 years. Professor William H. Pickering has recently correlated this with an ancient chronicle which states that in Cairo, Egypt, in the year 1029, quote, "many stars passed with a great noise." Unquote. He remarks that Cairo is about 100 degrees by great circle from Coon Butte, so that if the meteorite that made the crater was a member of a flock of similar bodies, which encountered the earth moving in parallel lines, some of them might have traversed the sky tangent to the earth's surface at Cairo. That the spectacle spoken of in the chronicle was caused by meteorites, he deems exceedingly probable because of what is said about, quote, "a great noise." Meteorites are the only celestial phenomena attended with perceptible sounds. Professor Pickering conjectures that this supposed flock of great meteorites may have formed the nucleus of a comet which struck the earth, and he finds confirmation of the idea in the fact that out of the 10 largest meteorites known, no less than 7 were found within 900 miles of Coon Butte. It would be interesting if we could trace back the history of that comet and find out what malicious planet caught it up in the innocent wanderings and hurled it with so true an aim towards the earth. This remarkable crater is one of the most interesting places in the world, for there is absolutely no record of such a mass, possibly an iron-headed comet, from outer space having come into collision with our earth. The results of the future exploration of the depths of the crater will be awaited with much interest. End. Chapter 11. Read by Greg Bell, Katy, Texas.